Well, now we're going to welcome Scott Soteric from International. He's going to talk a little bit more about trucks and tanks and all that kind of stuff. Scott also has an interesting travel stories.
Which one?
Which one? Pick one. The one today.
Oh, so I was driving up from Chicago this morning and see a big sign on the side of the road, I-90 closed at mile mark or whatever. I'm like, yeah, whatever. I'm from Chicago, so that doesn't mean much most of the time. So I get up there and it's backed up 8 miles. I'm like, ah, crap, late. And so after about 45 minutes, I get up to the casino right off 90, and there is a Mack truck which is completely jackknifed and is about 5 feet away from a lake. So that was my travel story for today. So I apologize for being a couple minutes late, but I obviously had a semi in the way. So my name's Scott Soteric. I'm a vocational sales manager for International Truck out of Chicago. And what my job is as much as to sell vehicles, it's to also educate our dealers, our customers, as well as our own internal sales folks on natural gas, as well as hybrid technology. So if you guys have any questions at the very end, I'll take a couple minutes. But what I'm going to do today is I'm going to sort of blow through a few different topics that I've been asked to talk about. So really what I'm going to cover is who are the players in the heavy-duty natural gas market. After that, I'm going to talk a little bit about what the OEMs offer. So even though I work for International, I also understand that not everybody buys an International, and we're going to go through the full scope of what all the competitors use as well. And then the last section I want to talk about is the actual tanks. There's a lot of technical detail behind the tanks and how it works from an OEM level. Here's some of the information that I want to discuss with you guys today. So there's really 3 companies out in the heavy-duty market, so class 6, 7, and 8 that do natural gas engines. And for the purposes of our discussion, I'm going to talk about companies that are both EPA and CARB certified. There are a variety of aftermarket retrofit kits that have either EPA certification or some sort of CARB certification. I know EcoDual is one of those as well, and I know they do have EPA certification for their Cummins IS. So that is something that I'm not going to get into, but I can provide contacts for them as well. So the 3 players are really Cummins Westport, Westport Innovations, and Emission Solutions Incorporated. So Cummins Westport is a joint venture between Cummins and Westport Innovations. So there's really 3 companies that work at this. So Cummins, Westport, that's a collaboration. There's also Westport Innovations. They make their own engines separate to Cummins. And then just at the Mid-America Truck Show last week, or 2 weeks ago, there was an announcement that Cummins themselves were also looking at a 15-liter spark-ignited engine as well. So this is what I'm going to discuss a little bit right now. Cummins Westport, their big player out in the market is the Cummins ISLG, which is basically a spark-ignited engine. It's 250 horsepower up to 320 foot-pounds torque. And to date, that's really been the dominant player in the natural gas industry. In North America, there's about 13,000 ISLGs available. They're serviced through your local Cummins distributor that's certified, and they're used in a variety of applications: refuse, regional haul. I've even seen some people try to do long haul with 320 1,000 foot-pound torque. And it's by far the most popular engine in North America for natural gas. Now coming up next year, Cummins Westport is going to be coming out with their 11.9 liter, so it'll be an ISX 11.9, and that will also be spark ignited. So that one will run on CNG or LNG, just like the ISLG. And just like with the ISLG, it'll be offered by pretty much every single OEM in the US. So that'll get you up to about 400 horsepower, 450 foot-pounds torque. So where today you have, let's say, a refuse guy, or let's say a regional haul customer that's looking to do 80,000 pounds on a regional route, they'll be able to do that because you're going to get a lot more torque and a little bit more horsepower as well. So there's a lot of excitement in the industry, and we're starting to see a lot of larger fleets start trying this different technology. We just had a large national account purchase 400 ISLGs in a regional haul application from International, and every year the volumes are slowly going up as we continue to move forward, and diesel, of course, continues to go up. Westport Innovations. So what Westport Innovations does is they take Cummins ISX, 15 liter, and they make a number of modifications to it. Basically, instead of being spark ignited, they do a technology called direct pilot or high pressure direct injection technology. And what that means is the injector actually injects the diesel first, then it injects the natural gas all through one injector. And so what happens is the diesel acts as a spark plug and ignites the natural gas, causing combustion. So there's no spark plugs. The diesel actually does the job as a spark plug. Now, the really nice thing about this system is you can get the really high horsepower and the good torque. The problem with it is that you need diesel, you need LNG, and you need urea. So you need all three, and it's very expensive. But it's a step in the right direction going forward. So that's a little bit about the Westport Innovations engine. And as you can see, you can get up to 475 horsepower and some 1750 foot-pounds torque. Now, if you're looking for something on the little bit smaller end, Emission Solutions Incorporated out of McKinney, Texas, they have done retrofit kits on International DT for a number of years, and it is now factory available. So you're going to go from 200 to 300 horsepower up to 860 foot-pound torque. And this engine is going to be more for dry vans. It's going to be more for some smaller refuse applications, some beverage tractors. You're not going to be pulling 80,000 gross combined with this engine. Right now, it's currently offered by International in our Durastar and Workstar models, and beyond that, ESI also does have, like I said, both CARB and EPA certification, and they do offer retrofits. So if you have an older International engine, a DT466 that you would like converted, that is something that they also do as well. All right, so market offerings. What is available, or what OEMs offer what? And that is sometimes a source of confusion. To be pretty frank, pretty much everybody offers the same type of options. Every single OEM offers an ISLG. And then a number of them, including Peterbilt, Kenworth, and Freightliner, also offer the Westport Innovations 15 liter in their product as well. Going forward, next year when Cummins Westport does come out with their 11.9 liter, pretty much the entire market will be going that way as well and have that option available. These are some of the models that Kenworth, Peterbilt, Freightliner, Volvo, Mack, and Autocar do have available today. Each of these engines have CNG options, LNG options. There's a number of tank configurations. You can get behind the cab. You can get saddle mounted. Heck, you can even have a bodybuilder, if you're doing a refuse application, mount them on the roof or inside the body somewhere. So there's a number of options. If you have any questions, feel free to ask at the end, especially on tank configurations for your bodies, because there's been some pretty creative options done. From an international standpoint, without getting bogged down in international too much, the ESI engine is available in our Durastar and Workstar. It's built at our Garland assembly plant down in Texas, and it's available in the Durastar and Workstar. All maintenance is done at our local distributors, and International is 100% behind ESI, and we have great faith in the product. It is built off the legendary DT466, which is a great engine, and for certain applications, it is a great option. Now, as we continue to evolve in natural gas, we've recently made an announcement which we'll be offering the ISLG in our TransStar at the end of the year, in the late summer, our WorkStar in the beginning of next year, end of this year, and then we're also launching a new cab over called the Lodestar, and that the ISLG will also be available in that when that launches next year. Now, the last product that we're working on is exciting because it's a different type of technology. It's called pilot injection technology. And the cool thing about this technology is that in most cases, you have to make a number of modifications to the engine in order for it to accept spark plugs or put new injectors in, machine out the pistons, machine out the head, change turbos, change ECMs, whatever it is. With pilot injection technology, all we're doing is adding another element to the combustion process. So today, when you have combustion, you have diesel, you have exhaust gas recirculation, and then you have oxygen, right? So when all three of those mix together, you get your boom, piston goes down, you create power. All we're doing is we're adding a little assembly which injects natural gas into the oxygen in the EGR. And the nice thing about this system is that, well, there's a couple nice things. One, you don't get any you don't have any loss in power or loss in fuel economy. So a ProStar running under this system would get comparable fuel economy to what a diesel Max Force 13 engine gets with diesel. So that's the one nice thing. The second benefit of this system is that there's very minor modifications to the engine. So you build an engine, and instead of building the diesel with all the components, it's all the diesel components plus this one little assembly that we package on. So our cost should be significantly lower than what a spark-ignited engine would cost to manufacture. So that, and you can also get the high horsepower. Right now, the prototype that we're working on is 430 horsepower and 1550 foot-pound torque. We're very excited about the possibilities that this engine provides. At a high level, it's going to go into our ProStar first, and that'll be for regional haul and long haul applications. And you can get anywhere between 400 and 800 miles to the tank for this. Now, keep in mind that this is dual fuel. It is not spark ignited. You need diesel and you need LNG to make this work. Now, if you run out of LNG, technically, you would be able to still run the engine. It'll probably go into limp mode, is what the EPA will make us do because of engine certifications. But you still need the LNG and diesel in order to get full power with this engine. So we are very excited about this, and we're hoping the end of next year, early 2014. It doesn't like me. All right, so and then the only changes to the chassis outside of the engine is you got your tank, a vaporizer to warm up the LNG into CNG, and then your regulator and filter just like a regular CNG chassis. So minimal changes. All right, my favorite part is the tank conversation, because this is where I get more questions than anything else. In the CNG, and I'm not really going to talk a lot about LNG, but for the CNG tank manufacturers, there's really a number of players. There's 3M, they make tanks, there's Quantum, there's Luxifer, there's Lincoln, and then for LNG tanks, there's Dart. Now, out of all those manufacturers, their tanks are typically bought by a third-party company called Agility that goes ahead and packages all the tanks together, puts their own regulators on them, they do their own certification, and then they sell them to the OEMs or the upfitters, and then the OEMs or upfitters install their assembly on a chassis. So I'm sort of going to go through Tank 101. When we talk about tanks, a lot of folks are curious, well, why in the world do I need that big of a tank to get me 60 gallons equivalent to diesel? And I always like showing this chart because this gives everybody a really good idea of why you need bigger tanks to get the same amount of fuel. So diesel has about 130,000 BTUs, so British thermal units. That's how we define how much energy is derived from that particular fuel. So for diesel, it's about 130,000. For CNG, you're going to get between 38,000 and 44,000 BTUs per gallon of CNG. And then for LNG, so natural gas in liquid form, you're going to get about 73,500 BTUs per gallon of LNG. So what we've done is a mathematical formula saying DG, so a diesel gallon equivalent of natural gas is more like 3.5 gallons of natural gas is equal to 1 diesel gallon. So when you go to the tank or the fueling station and fill up, you're actually going to be filling up 3.5 gallons of CNG, but it'll only say 1 DGE to make it simpler on all of us. LNG is a little bit different. I'll talk through the conversion on that going forward. All right, so CNG tanks themselves. I sort of talked about the different builders. Those are really the big ones. Now, as far as characteristics of tanks, you have a couple different options. In the last presentation, you saw the Type 1, Type 2, 3, and 4 tanks. I'll go through that a little bit. They're either steel or composite in nature, or some combination of both of them. Outside of that, in natural gas, you're going to get between 15 and about 80 DGE configurations on your chassis. So depending on how much range you need, we have a number of options. Tanks today typically last about 20 years, is pretty much the life cycle. And if you have a chassis that lasts much longer than that, you're doing pretty good. As far as the pressure release, the tanks are actually engineered to take about 2.25 times the working pressure. So even if you got up to even 5,000–6,000 PSI, the tanks are still rated to work, although that's not the optimal condition. So there's very little risk of the tank just blowing up. And I'll talk to that in a little bit. Along with that, there are a number of pressure relief valves on each tank. So if there is an overpressure situation, it'll just vent into the atmosphere. Now, this is something that's really important is for natural gas tanks, they really need to be checked by a certified tank, by somebody that is certified into checking tanks at every 3 years or 36,000 miles. So depending on what your duty cycle is, that could be once or twice a year, depending on how many miles you have. In addition to that, if there is any accident, you also need to have somebody take a look at your tanks. That's really important, just because of vibrations and so on and so forth. You really want to make sure that the tanks are working correctly. And that is a FMVSS rule, along with the 50 million other FMVSS rules. All right, so there's 4 different types of tanks. There's Type 1, which is all steel, very cheap, very heavy. There's Type 2, which is steel with a composite wrap over the middle. Less steel, more composite. It's a little lighter, a little more expensive. There's Type 3, which is even less steel, so a steel inner loop, and then composite outer wrap. Less steel, more composite, a little lighter, even more expensive. Type 4 is what we put on our chassis, and that's an all-composite tank. So it's very light, very expensive, at the very high end of at a brief description. This is sort of what the tanks look like. Depending on your application, it can vary greatly what you actually need. Generally speaking, like I said, from the factory, it's all going to be Type 4, which is in the bottom right-hand corner. So that'll give you an idea of pretty much class 1, 2, 3, or 4 tank looks like when you take a look at it just from the outside. All right, so good old government regulation. So there are a number of different certifications for natural gas tanks and LNG tanks. If you live in California, you're very lucky, you get even more. Or if you live in Canada or Texas, you get a little bit more. For our purposes, we're going to worry about NFPA 52 and then also 57 for LNG. And so I'm going to sort of talk a little bit about what the manufacturers have to go through in order to get them certified. It's actually, if you guys like blowing stuff up, it's actually sort of a fun job. Corey wants to blow something up. All right, so there's a number of tests. The first one that the tank manufacturers have to go through, and this is just to instill the confidence we have in these tanks, is a hydraulic cycle test. So basically what they do for this is they put water in the tank and they continue to pressurize it up to a certain threshold. And as long as there are no leaks, it has passed the test. The second test is a low temperature pressure testing. So it's the same basic principle. You're going to pressurize the tank with water, but you're going to drop the temperature to -40 degrees, and then you're going to rise it up to 159 degrees. And that simulates the unloading or the filling up of the tank and then the unloading of the tank over a period of time. So any sort of leak in that is also considered a failure. The third one is a drop impact testing. So if anybody's got a crane and wants to drop tanks from between 10 and 30 feet, give or take, they drop the tanks at multiple different angles, at multiple different heights, and basically what they're looking to do is make sure there's no significant damage to the tank. The next one's the fun one, bonfire test. So let's say there is a fire, right? We want to make sure that the tank does not, boom, explode, right? So what they do is they fill up a natural gas tank and they put it in a fire, and they actually see how long, well, when a natural gas tank gets in contact with an open flame, the goal of it is to vent directly into the atmosphere, but to not explode. So that's what that test does, make sure there's not an actual explosion. You'll see the natural gas come out in a couple seconds, and it is a fun test. There's a couple of videos that I could have put in here, but I didn't. I apologize. Environmental exposure test. Basically what this one does, and I'll read it, they put salt, battery acid, gasoline, fertilizer, and a number of other items on a tank while they're cycling it. So if it can live through the crap that our wonderful DOTs put on the road, it can live through just about anything. The next test is a gunfire test, and I don't understand why they do this outside of somebody wanting to shoot at something. I agree. So they shoot at the tanks and make sure they don't go boom. So at a very high level. So the next one is a vibration test, which is the same basic principle. You're going down the road, the tank's going to be vibrating from the bumps in the road. They do testing on that. Hydraulic crush test. Basically what they do is they pressurize it and then they try to crush the tank to a certain level, and as long as the tank doesn't have significant damage or is unsafe, it's passed. And the last one is they just sort of drag the tank behind them on the road. So that's another fun one. I'll let you know, Corey, if we... So with all that being said, there's no presentation without fiery car accidents. So this is a bus that had an engine fire, and those are type 2 tanks up top. Those are type 3 tanks on the right-hand side at the very bottom. The tanks vented properly, and all the fire was caused by the engine. So we did not have any issues in that specific incident. So that's a really good example of how safe. That bus is completely charred, and there was no issues with the tanks. They vented correctly, very safe. They did exactly what they were supposed to do. The next one on the right-hand side, that is a Civic that got rear-ended. Once again, the tanks vented correctly, and there was no fire from the tanks, which is exactly what we want. Now the bottom one, that one was one where 2 vehicles had an accident at 50 miles an hour. The gas vehicle actually caught on fire and got the other vehicle caught on fire, or got the natural gas vehicle caught on fire, but the natural gas tank vented properly again, and we did not have any sort of incident to the natural gas tanks, which is exactly what we want. So I apologize, I don't have more, but. All right, so as far as tank packages, it really depends what you're looking for. Every application's a little bit different. There's really saddle-mounted tanks, behind the cab mounted tanks, or there's roof tanks, there's tanks in the body, there's a variety of options. Most OEMs, including international, they'll offer you a couple different options. One would be something like this. This is a tractor package, so you get 40-gallon DGE on one side, 15 on the other, and that's for tractor, so you can keep the wheelbase somewhat short. The other options are you can get 40s on each side for a total of 80 DGE, or the one on the far right is behind the cab, where you can get 60 to 75 DGE from the factory. And the downside of that is that you lose about 24 inches CA, so cab to axle, you lose about 24 inches of space. In addition to that, if you have like a tractor, Your wheelbase gets a lot longer, and where your drivers used to be able to make a turn, they no longer can make that turn. So that's really popular in certain applications, specifically dump trucks. That's really popular. If you want clean CA, that's another popular option, but if you're a tractor, something on the frame rails is going to be your best bet. We also offer a left-hand side 40 only or right-hand side 40 only. So the really nice thing is Agility offers somewhere around 28 different packaging options. So if you have something that you're interested in, you can always ask, and more likely than not, we can get it for you. And with that being said, if we can't get it for you and you have a bodybuilder that is comfortable installing tanks, we can ship the engine from the factory with no tanks, and the bodybuilder just installs them as well. So that is also another option. All right, so LNG tanks. Now these things are unreal. So LNG is not found in nature, right? It's super cooled to negative 260 degrees, and then it's put on a truck. And as everybody would think, at negative 260 it would warm very rapidly, turning into natural or CNG, and then would vent into the atmosphere because of the increased pressure within the tank. How these tanks work is that they have an inner wrap where the natural gas goes, then they have an outer wrap, and then they have insulation in between the two, and it's vacuum sealed. So do I have anybody here that's pretty handy? Does housework as far as construction? So you look at insulation inside the house. What is the insulation at a house? R15, R30? So R30 is sealing. So R30 is an insulating factor. That's what you have in the walls of your house. The insulation in these tanks is R5000. It has the highest insulating property of any insulation in the world. So it's pretty damn cool. If you had this stuff in your house, you wouldn't even need to have a heater. So basically between those three things, the vacuum seal, the inner, the outer, and then the 5000R, on the new tanks you can get, if you fill up on a Sunday with LNG, the next Sunday you're still going to have fuel. Now, if you wait for 2 weeks, that LNG is going to go from negative 260 and then it'll slowly go down, turning into natural gas, causing pressure. The tanks will then vent off the natural gas. So at about 2 weeks, you're not going to have any gas left. So with LNG, it's sort of a use it or lose it sort of scenario. Now, people want LNG because that BTU table I showed you, you can fit more energy in a smaller tank. So if I'm a long haul tractor driver, I want to get more miles to the tank rather than maybe going 200-300 miles. Maybe I can go 400 or 600 miles with LNG. And that's why there's really the interest. In any application where you're coming back on a daily basis, you're probably not going to be using LNG. LNG, from what we see, is best for over the road. CNG is best if the vehicles are coming home every day. Not to say that that's the hard and fast, but that's generally what we see out in the marketplace. All right, so LNG, generally speaking, you'll see a slide in, it'll say like 120-gallon LNG tank. And unlike natural gas, it actually means 120 gallons of LNG, not of a diesel or gallon equivalent. So if, let's say, you have a 120-gallon tank of LNG, you're going to get about 55 diesel gallon equivalents of LNG. So if you have 220-gallon tanks, you're going to get about 110. So CNG, we do it one way. LNG, we do it a different way. So it's a little confusing, but just keep that in mind. With that being said, Corey, do we have any time for questions? Or?
Yeah, a couple of questions, sure.
Have at it, guys.
Here, LNG to CNG.
Yeah.
What kind of price differential?
Well, the LNG goes. All right, so what is the price differential between CNG and LNG? LNG is going to be more expensive. It's manufactured, usually comes from fracking or from a well somewhere. It's got to go to a liquefaction plant. They purify it, and it gets slowly cooled in processes. So it might go to negative 100, then negative 200, then negative 260. Then it's either put in a boat or put in a tractor and shipped to a station. With CNG, if you have a pipe, you that gas up to 3,600 PSI, and you have gas that you can use in your truck. Most of the people that have LNG stations are going to be clean energy, and clean energy sort of dictates the price based on competition. So it really varies. But yeah, it would be more expensive than CNG. So there you go.
I'm sorry. At our station in La Crosse, quick trip is selling both LNG and CNG. The state has mandated that you sell LNG in a diesel gallon equivalent.
Okay.
And so it is price point right now at $2.69 for diesel gallon equivalent of LNG. And CNG, right now we have our CNG at $1.59 per gas gallon equivalent or GG.
So it just sort of varies, as the gentleman said, depending where you're at, and the LNG is going to be a little bit more expensive.
So are you putting that in, is that coming into the truck as LNG and then you're converting it?
Well, build in full redundancy, what we did is 2 different steps. We have in the pipe through our micro and nano box aspect, and we can allow that. We have what we call LCNG, which takes that liquefaction. It's got a 15,000 gallon tank to charge, and then it will compress it down into CNG if we want to make it into CNG. Otherwise, we can feed it in as LNG.
Yeah, but if you do a Google search on a liquefaction plant, you'll be amazed at how, yeah, I mean, they're huge and they're pretty wild. Any other questions?
That's everything. Yep. No different than you would purchase gas and
I saw another hand back there. Good. No. No, it will not. It'll be diesel and LNG.
So how are you getting away from the DEF aspect of the regulations for, is it due to the percentage of diesel that's going to be utilized?
Yeah, so how EPA and, EPA and CARB have a number of points. There's a not to exceed, and then there's 13 points they test at. At none of the 13 points are we over the not to exceed, and at an average we'll be at 0.2 with the LNG and the diesel. So now if you run out of LNG, it'll go into a limp mode, just like a diesel, let's say Freightliner, Kenworth, or Pete. When you run out of urea, it'll go into a limp mode. We'll do the same thing. Any other questions? I appreciate your guys' time. I do have cards. I apologize I didn't put contact information, but come find me afterwards and I'll give you guys a card. Thank you.